Hello, everyone, and welcome to Digital Transformation Council's Best Practices webinar. Thank you all for joining us today. I'm Preet, I'm part of the ARC team. And today we will hear from Data Park and WR Grace about developing effective process monitoring systems. We expect our meeting to be an hour long and it'll be recorded. Now I'm going to hand it over to my colleague, Craig Resnick, who will go over about more meeting details. Craig?
Hey, thanks a lot, Preet. Again, Craig Resnick with ARC. Really excited to have this presentation from WR Grace and Capstone Technologies Data Park. You know, one of the things that we all know is that real-time process monitoring systems, really play a critical role in maximizing process efficiencies and product qualities. But, the importance of enterprise-level process monitoring, really can't be understated. It's pretty common for monitoring to be done in specific process areas that even have like a site-wide visibility into process conditions. But something that is a common goal of most digital transformation efforts is really the ability to have all the data from all the plants visible at the corporate level. And, this is becoming a common goal. And, the idea was developing, even certainly before COVID struck. But at companies such as WR Grace, that had this real-time process monitoring system that was already set up, they were in a great position to kind of keep an eye on production and even, troubleshoot and suggest process changes while they were working from home or away from the plant. And this really enabled WR Grace to improve product quality and increase process efficiency and provide process visibility to everyone within the organization, whether they're on site or whether they're remote. I mean, it included, think of it, integrating process and quality data, creating shared process dashboards and KPIs and remote monitoring capabilities, developing predictive quality models and building early warning systems for quality issues and sharing process data across the enterprise. So, I think you're going to really enjoy today's webinar, and it's being sponsored today by Capstone Technologies, Data Park's decision-making platform, which is used by engineers and operators and plant managers and other process industry users to provide real-time visualization and access to data in order to solve operational challenges and maximize efficiency and optimize operations. Their effort kind of began in 1980 when the founders of Capstone developed this in-house data acquisition and analysis system to kind of bring better insights to the plant. And it eventually rolled out enterprise-wide, serving as a mission-critical control system for plants all over North America. And the company was formed in 1997. And, today there's hundreds of Data Park installations across the process industries, in oil and gas and pulp and paper, power and utilities, chemical, refining, mining and metals, and food and beverage. So we really look forward to having this presentation today. So we're going to start off with Patrick Bundy from Data Park, and then followed by Ryan Sullivan from WR Grace. Really looking forward to both their presentations. And then when we're done, we'll get into a Q&A session, and then we'll make some concluding remarks. And, this is also part of the whole ARC Digital Transformation Council, the new industry best practice webinars for users. We're always trying to make sure we get you as much timely and topical information as possible. This happens to be a meeting that's available to members and non-members alike. And so because of that, because it's a non-members meeting, we do allow this meeting to be recorded, for your convenience at a later time. We welcome your questions. You'll see on the bottom of the screen, there'll be a Q&A button. Try to use that if you want to leave some questions live, and we'll get to that, once Patrick and Ryan have finished their presentations. So without further ado, I'd like to introduce Patrick Bundy, business manager from Data Park. He will start the presentation off, and then he will pass the baton immediately to Ryan, and then we'll get to our Q&A later. Thank you so much.
Thank you, Craig. Welcome, everyone. Thank you for joining us for today's webinar. My name is Pat Bundy. I'm a business area manager for Capstone Technology. And Capstone, as Craig said, is a leading provider of software and services for process operations management and includes providing data analytics and data visualization to a wide variety of stakeholders. I'm going to pull up just a short presentation before we hand this over to Ryan. Today our presentation is, let's see, I'm gonna just jump over here real quick and get this presentation started. There we go. Today our presentation is on developing effective process monitoring systems at W.R. Grace, presented by Ryan Sullivan, a longtime production engineer, and now Ryan is a logistics supervisor. And Ryan works at the Grace Chemical facility, the largest U.S. Grace Chemical facility in Curtis Bay, Maryland. Welcome, Ryan. So developing effective process monitoring systems is the topic today, obviously, and then a little bit about Capstone before we begin. Capstone has been around really for 40 years. The first 2 decades, the core of the company that began the company, they were in an industrial manufacturing facility, and they had a need back in the 1980s for a data historian and data visualization. And they went out to the marketplace and really couldn't find it. And they needed something that was above the control system so that process engineers and operations and quality and managers staff could get together around a centralized set of data visualization analytical capabilities and functions. And so those first 2 decades, they were in the plant, and they were so successful with it, they stamped it out at multiple plants within the corporation. They jumped out and formulated Capstone, and for the last 2 decades or so, have been building this real-time data visualization analytics package. And they got their start in pulp and paper, but really they've made some great inroads into chemicals, oil and gas, refining, minerals and mining, consumer packaging, many different markets. We're in over 800 facilities around the world in 25 countries. And Capstone is headquartered in Vancouver, Washington. And we're a Voith company. And Voith, founded some 150 years ago, headquartered in Heidenheim, Germany, built some of the first paper machines. And they also built technology around hydropower and turbo and digital ventures. So they're about a $5 billion company in 60 countries with 20,000 employees. So process monitoring tools involve a number of different things to be successful. So data integration to multiple data sources, real-time monitoring, of course, graphics and dashboards, notifications, calculations and analytics, and all of these things done very, very quickly. The quicker they can be done, the better when an engineer and operator needs something at his fingertips. And we also have incorporated a modeling package, which we work with Dow Chemical, partner with Dow Chemical to put together to make easy access into our system. We also have a reporting mechanism with a scheduler and remote and mobile capabilities as well. And so what sets DataPark apart? It's the ability to come in with your current infrastructure and just sit it right on top of your infrastructure and connect to multiple systems. And then also to have great tools at the user's fingertips. And traditionally, you would have to pull data out of the system and go and do a lot of work, typically around Excel, and then bring those results back into the online system. Well, here, many of the functions are real time, and you immediately get you can get your work done and get the results back in within minutes rather than waiting for hours. So the data is fast as well. You may know Hadoop, which is a map reduction technology, which your cell phones use when you're doing searches through Google, et cetera. Well, we have a performance data engine, which speeds the data to the user. And then ease of use is important as well. Many folks claim ease of use, but DataPark has many of the key functions are very easy to use right out of the box. And we see so many staff gravitate towards using DataPark because of that ease of use. So when you talk to our customers, they say it's one of the top 3 to 5 important features about Data Park. And then we have a lower TCO than almost all the companies who provide these kinds of functions. And then we have also, I wanted to highlight the fact that we have a short project timeline. Typically, we have 120 to 240 hours to do a project, to get that project in and on and off the ground. And so the timeline is relatively short. And as you can see here, just going back to the multiple data connections, whatever data systems you have, whether they be Honeywell or Aspen or OSI, or if you want to connect the ERP, or even if you don't have a data historian, we can connect to the DCS and provide you a data historian as well. Here's just a quick glance at key customers, and I'll point out to you just a handful. Of course, W.R. Grace is with us today. And then we also partner with the Dow Chemical Company and have many plants there, probably along the lines of 25 plants or so in which we're working with and monitoring. I like to point out Saudi Aramco's S-Oil refinery in energy transfer. So we have 6 facilities at Grace, within Grace. We have 400 facilities within energy transfer. In 2016, the Saudi Aramco refinery, it was the 4th largest refinery in the world, and they completely replaced their OSI PI system with Data Park. And of course, I mentioned the 25 facilities that we have at the Dow Chemical Company. So without further ado, I'd like to introduce to you Ryan Sullivan, and I'll let Ryan tell you the story of Curtis Bay and how they're using Data Park there. Ryan?
Yeah, so I'm just going to get my presentation up here on the board for everyone. All righty. So just want to give a little bit of a background about myself. Like Patrick said, I've been a production engineer here at Grace for a little over 3.5 years. Just recently took on the logistics supervisor role starting in January. So it's an exciting change of pace and an exciting change of a way to actually do this effective process monitoring from a different perspective, not just with process production data. So without further ado, let's get into developing effective process monitoring systems. So a little bit about Grace. We are primarily a specialty catalyst business here at the Curtis Bay facility. We are a 1 million square foot facility with about 600 employees. And basically our primary products that we put out of here are FCC catalysts, hydroprocessing and hydrocracking, polyolefin catalysts, and specialty silica gels, which is my area of expertise. We are both an analytical and a manufacturing facility, so we have a dedicated lab on site for all of our products that processes not just our stuff, but other sites as well. So we get and like Patrick said, we are the largest U.S. manufacturing facility, so we do see a lot of our HQ business from Columbia coming our way as well. So to kind of understand how we moved forward with effective process monitoring, you have to understand where we came from. And if anyone saw my presentation last year, we were primarily in the IT-OT convergence phase, and we have moved a little bit beyond that. So previously, our system, our Process Studio system, very simple, not a lot of work could be done with it. You could put multiple trends in a graph, and that's great, but you really couldn't manipulate the data or view it in any way that allowed you to save time for solving process problems. Speed of that data access was horrible. I think some of my more robust trends that had 5 or 6 tags on them would take upwards of 30 minutes to load, especially if I'm looking at it over multiple days. Ineffective user interaction. I could not look at lab data and process data both in the same place. I had to do different windows, different comparisons, and really no effective timeline comparison. And like I said, lack of lab data, no ability to bring lab data or any IT systems into this software. So basically separate programs, not just for lab data, but any online databases we had that we've been using, especially for documents, all of that, separate systems, separate windows, a lot of comparison. So requirements that we had for effective process monitoring basically boiled down to these 5 things. Performance, the ability to have high-speed data rendering, as instantaneous as we can get it. Compatibility, the ability to use a system with different servers, especially our PhD and lab systems. expandability, the ability to any new systems that we bring onto site can actually be implemented into the data park tools. Reachability was a big one for me when I took over this project, the ability to reach out from not just operations, but to engineering and the corporate level as well. Everyone having access to any data that they deem necessary, and then seeing an actual improvement on the site. It's one thing to just bring in a new system. It's another to actually see improvement. Reaching faster solutions to process upsets was the big focus at the time. So where did we start? Like I said, last year, we had a robust operations technology information system, but really no way to use it. Difficulty with multiple process tags in a graph, no manipulation of data. Any manipulation you could do is basically making a 0-1 signal on and off. And that's great, but it doesn't tell you anything different than a 0-1 graph. And the biggest thing was only being used by engineering, and even then, it wasn't really broadly used across everyone. Both some of the new engineers and older engineers didn't really understand the system and found that the Honeywell HMI was faster to use, which is terrifying. And then we had no operator buy-in as well. So on top of that, we had a non-existent IT system integration. 3 of the big systems that we have here is our Equal database, where all of our online documents are kept, basically getting away from paper and onto online. Our GLIMS database, which is basically all of our site lab information, and then SAP for just about everything else. So basically what we saw here is we had our IT world and OT world, basically no communication between the two. And that was unacceptable for us. So what we did focus on is basically a one-size-fits-all approach, something that could use all of this information together. So these were the things we focused on. Like I said, performance, instant access, fast loading, which we'll get into a little bit later. The reliability, the ability to pull information up to 3 years back. That's incredibly important when troubleshooting, especially from environmental standpoints. Compatibility, integration with all of our Curtis Bay IT systems, and the ability to expand into anything else. Accessibility, enterprise-wide access to process information, not just on-site, but off-site as well. And we'll get into that a little bit more as well. Complicated process analysis, basically the ability to take information we currently have and manipulate it into anything else we need. A good example of that is I use our changes in weigh cells to determine a slope that tells me if something is feeding out too slow or too fast. It had to be cost effective. Like I said, we wanted to see reduction in plant downtime, our cost of poor quality go down, and increase our first pass quality rate, which I have a great example of later. And then probably more applicable to any time than today is the mobile communication aspect, the ability to know when critical operations fail from anywhere. Sorry about that, phone's not on mute. So basically where we ended up is we finally got to see our IT world and our OT world coming together in one user interface that allowed us to implement maximum asset performance with efficient operations for basically all of our plants here. So getting into a little bit more about the data integration aspect, we are a 24/7 manufacturing facility. Our old system was a Honeywell human machine interface. If anyone has seen it, it has poor trending ability, no detailed information on point values, and it's really hard to tone in on specific anomalies, especially when all you have is an arrow on a keyboard. So if anyone's seen it, this is kind of what it looks like from one of our displays. You can, any one of those white squares, you can hone in on that data. And if you wanted to, you would get a detailed point of it. And if you actually wanted to trend it, you'd have to go into that detail and then actually trend it. And something that's key to note about this very far graph on the right is this is actually 8 points, and the additional 7 that you want on there, you have to manually type them in and add them. So you can imagine adding just 8 points to look at them over time can be a little bit cumbersome. And when you have over 55,000 process tags, it gets really, really cumbersome trying to solve process upsets that are costing you money. So when we get into the system integration, not just using our PhD servers, one of the big ones I'm going to talk about, and this doesn't even remotely cover all of them, but the biggest one is our GLIMS database, which allowed us to bring in detailed lab data monitoring. Basically anything from a raw material to our finished product, if it can be tested, it could be overlaid into Data Park and viewed in real time. The simplicity of this is it actually allowed us to just any new templates we wanted to add to the Data Park system was a simple email to our help desk ticket or our help desk, so we didn't have to overwhelm the system at any given time. So basically, this is what it did look like. and still does if we ever need to drill down. But as you can see, you have to look at each individual point on a small basis. And even that trending ability, you can see from the x-axis, it's really hard to hone in on exactly what's going on. This is basically what it looks like now with actually an SQC monitoring aspect put on top of it as well. So basically we went from inadequate trending to detailed trending by just implementing one system. And it's important to note that this doesn't even have process data on it yet. This is just being able to pull up our GLIMS data basically instantaneously. So when you bring all of that information together in one place, this is basically what it looks like. This is one of our raw materials that we make up to use in the process. It's important to note that on here, we have in-process data, both our pumps and our tank levels on the top three. This is the actual makeup data down here. And then we have our GLIMS data, our lab data with both real-time lab analysis and its SQC and control stuff implemented as well. So this is an incredibly important thing for me because I can come in or get notifications saying that our batches did not make up properly, or we didn't make up enough for the time frame in which we're trying to make material. And basically what would have been 8 windows is now all loaded up in this singular window right here. So basically, like I said, you have the data park multi-trends, it's Smart Mouse, which shows the real-time information as you overlay it, the lab integration data, alarm notifications, which I'll get into a little bit more later, SQC monitoring for any critical to quality stuff, and custom calculations, like I said, to tell me I can do counts on how many batches came out, which I don't currently have in our PhD system. And then any manual data entry, which is huge for raw materials, CFAs that are coming in, and you want to look at that CFA data in real process time as well. So all of that combined basically leads up to a much more effective process monitoring system that we now have here at Grace. So I've talked a lot about speed. I don't think there's any better way than just to show you. So this is just a quick video of myself opening up a trend that I look at every single morning and just hitting play. You can see myself click it right there. And as great as that view is, unfortunately, it doesn't stay there long because everything loads pretty much instantaneously. So like I said, all of those systems I talked about earlier, the multi-trends, the alarm notifications, the lab data, all of that was about 15 seconds to pull up that. I open approximately 25 trends every single morning with a script, and it's about 3 to 5 minutes to actually pull all of that up. And an incredibly important thing to note about this video here is that was all done while I was at home over a VPN. It's much faster when on site. It's incredibly impressive to see it load that fast on my horrible internet at home. So moving on, another aspect is creating dashboards and KPIs that you can actually see. Basically taking all of that detailed information and consolidating it to a much more simplistic view, not just for myself, but for operators and corporate alike. Basically, you have the ability to convey critical process information to operations in a small window that they can use to basically empower themselves to make decisions on their own. And this is a big project that I've been working on right now, both in my old role and my new role. Basically, the less time they can spend communicating with other people to either gather information, the more time they can go out and make decisions. So basically, we focus on simple, centralized, and customizable dashboards that could be used by managers, operators, engineers, all of which can have a custom view for even the same information, something that caters to them. This is a good example of our manager dashboard. This is something that the manager for one of our alumina plants can come in, look at, and determine if the plant is running in the efficiency that it should be. But on top of that, we keep this dashboard with a little bit more detailed view actually in the control room for operators. And this is how it kind of looks in the control room, is they can dive in on specific stuff, to dive in on either tank levels, in-process lab results, or even process data, all with a single click just from this dashboard, which basically allows the operators to drill down on problems faster than having to wait for the engineer to tell them what to do. They can actually see it in real time. I think there's no better expert on how equipment runs than the operators themselves. This is another application of that, simple centralized dashboard from my new perspective as a logistics manager. One of the big issues that we have is communicating these packets that are about a couple inches thick that show what needs to be pulled, what lots need to be associated with the said orders and the time frame in which they need to be ready. It is hard to coordinate via just a thick packet what the priority is for the day. So this is a dashboard with some mock-ups of our open orders and allocations that they can actually see on a large display at their workstation that tells them the tank levels if they have the ability to receive raw materials for that day. Basically, they have cutoff values. If they don't meet the cutoff value, they have to turn away the truck. It tells them the status of what we have in my plant called a blender. Basically, it's an extra task for our logistics people to package out material. This basically tells them, is it ready for them to start blending? If not, they can focus on other tasks. And the biggest one that I'm very eager to have out there is our open orders and our allocation reports. When they walk in the morning, they can glance at this and say, I have these orders that are going out today, and they are composed of these lots. You can kind of see that here. Orders versus actually makeup of the material, and both the quantity and the number of drums, the drum counts that go into them. That means that instead of relying on me to give them information or our admins to give them information, they can make those decisions for themselves and start doing their work as soon as they get in for the day. So moving on to a little bit more of the remote monitoring capabilities, especially in today's world, bringing the process home is incredibly important for production engineers, process engineers who need to make sure that the plant is running in a 24/7 capacity. Production is 24/7. Unfortunately, my workday isn't most of the time. But being remote is not just being at home. It's a wide application of communication. It's when you're offsite in general, whether you're out and about or sitting down watching TV, bringing home weekend notifications, reports, process alarms for critical to process properties, and just outside of operations group, communicating reports to corporate and R&D who may need real-time information to make their decisions on how to move forward. Basically, you move from an out-of-sight mindset. Does not have to mean out of mind. It just means you're getting it in a different manner. One thing that we saw here at Grace, at the time to resolution for major process quality upsets decreased. And actually, as a consequence, I wouldn't say as a reward, we saw decreases in cost of poor quality and an increase in our first pass quality rate, which I'll show you in a moment. We also saw a major improvement in communication between our engineering group and our plant floor. I know for me, having the ability to get a notification that something is out of spec on the weekend allowed me to make a quick phone call into the plant rather than getting blindsided with it on Monday morning. And especially in these times, COVID-19 is a reality. A lot of us are working from home, and myself especially just spent about 5 months on a 3-week rotation with 2 weeks being off, 1 week in. Having all of this information consolidated remotely in one place allowed me to make decisions faster and actually keep our plant running as effectively as we could, if not the same as we would when I'm here. That is critical that I had that information, and I don't think having anything else would have been sufficient enough. So talking a little about that remote monitoring, we get into probably the simplistic aspect of it is having process alarms give instant upset feedback. Custom process alarms based on the operating conditions are critical to my role when I am not there at the plant. Basically, we could send instant notifications, but either to email and phone, both of which I currently use. We can also assign issues to the process upsets that allows us to do some future troubleshooting and predictive monitoring. And this is what that system looks like. This is where you could create a custom alarm. This is what it would look like if you wanted to see the list of alarms. And this is what it looks like actually in a trend. So you can actually see in real time stuff out of spec. But more importantly, from a remote monitoring aspect, this is an email that I would receive as well as a text message, which I don't have a photo of, that I would get in real time, showing me and actually linking me to the trend so I can know exactly what's going on. And where we start to see that, especially, we start to get warning shots for my plant. And this is a great trend that I use all the time on the weekend. We have a big issue with one of our specifications going out of spec, always on Friday evenings, that takes about 3 days to actually come through into the final product. But now with this early warning system and the alarm notifications, I can actually get these before they show up down here in my finished product. So this warning shot that I get in on the weekend, I can call into the plant, say, hey, we have a problem, check out our wash pots, and also start segregating material so that we don't make any out of spec product. So like I said, early warnings basically means a phone call into the foreman's office and the issue's been fixed. It also means that if I have those early warning shots, I don't get blindsided like I mentioned earlier. What I used to experience prior to doing full implementation of these alarm systems is I would come in on Monday morning, I would have a slew of foreman's notes, a backload of bad lab data, and I would have to try and figure out where it went wrong over the weekend. With these warning shots, I basically come in with a starting place for Monday morning. I know exactly where to look at, which in this case would be that the equipment for those lab trends that I showed you, and then I can start drilling down where the actual issue came from. Has saved me probably hours of work every single morning at Monday morning, just solving problems. And so you start to get your quality management with data on the go, and you can predict your first pass quality deviations before they even happen. So this is a more simplistic view of those two graphs you were looking at. But basically what we saw from a quantifiable standpoint, in 2017, we had a cost of poor quality from these weekend incidents costing about $280,000. And unfortunately, it's not a lot of material to cost us a high cost of poor quality. But in 2018, we saw that drop to $52,000 just from having these warning system warning shots go out to myself during the weekend and the foreman and other engineers. But being remote doesn't mean just having it on the weekend. It also means troubleshooting when you're at home for major process upsets. This is something that happened very recently that I am very proud of that we were able to get solved. I got a phone call at 3 a.m. after having an extended shutdown, which you can kind of see in this bottom portion right here. I got a phone call at about 3 a.m. in the morning, basically saying that they were having vacuum issues on one of our major pieces of equipment. What I was able to do was actually open up this trend, take a look at the historical data, and tell them that it looks like our bag house is past its lifespan, which you can see down here, this 23 days. This is how long it was running before we went into the extended shutdown. And just from process knowledge, actually, that I've learned from this system, I knew that the filters that were in that bag house were at the end of their lifespan and that they needed to be replaced. So what basically would have been boots on the ground, having to come in and break down the equipment, possibly clean the equipment, turned into basically a 30-minute debacle of just saying, hey, switch to the next bag house, replace the filters, and we'll be good to go. And sure enough, as you can see kind of vaguely right over here, that's where we made the switch and everything was running the way it was supposed to. You can see the purple and yellow kind of going in and out of whack. That's where it was not running properly. And then we switched to our new system. Everything's good. So like I said, hours of troubleshooting, boots on the ground, basically turned to in 30 minutes of remote walkthrough, and we were back up and running with no issues. A little bit about predictive maintenance and predictive monitoring. Something that we haven't fully yet implemented, but still have the capability to do is being able to turn if our process upsets are actually real. It's not true predictive maintenance yet, but it is able to help us determine how we move forward. This is using those alarm systems. We can basically assign values to any time something goes out of whack, and we can actually move from, in this case, this would be similar to the bag house example. I can determine whether the process upsets that are happening are real or if they're just part of the normal process deviation. What we saw is basically from here, this is an instance where it's just normal process deviation. We then found in this case that our bag house was failing, and this would be the clear indication of that. And we could tell our operators and foremen to switch over to new equipment. So kind of some of the benefits and performance matrix and breaking it down and how we're using it here at Grace. Effective process monitoring is decreasing the communication gaps and increasing our production. There's no question about it. The hours of time that were spent troubleshooting are now hours spent making material, and decreasing those communication gaps between engineering, operators, and corporate has allowed us to make better business decisions moving forward. The integration of all of our systems into one user interface is really the key factor in this effective process monitoring. The lab data is accessible to anyone here at Grace. Equipment status is available anywhere that it basically has internet. The advanced modeling that we can use for kind of strategic forecasting on whether equipment's going to start to fail And then that statistical process information for predictive maintenance, like I just talked about, has really, really helped us with effective process monitoring. And then, like I said, on the fly process notifications, being able to know how the process is running at any given time. And so what we've basically saw is we've moved from our IT OT convergence phase that was just being used by engineering operations to now anyone can be involved with a process monitoring at a site. Anything can be customized for anyone. We have a fast and frictionless interface, which is key to adoption. And then the biggest thing is, like I said, increased our learning. The offsetting the knowledge gaps between engineering, operations, and corporate helps everyone make better decisions moving forward. So kind of where we're at right now and how we want to move forward is basically knowledge of the system. We're continuing to help people understand both the data park system and the site itself. Basically, the more people that understand the tools that we're using, the more you can rely on our legacy systems like our PhD servers for process information and make decisions faster. Some of the current projects we have in motion is we're creating our critical to quality site-wide dashboards, which means instead of just the quality group and maybe just the engineering group looking at quality information, the operators are aware of it, corporate is aware of it, and they get to see that information in real time. They're no longer waiting on weekly, monthly, quarterly reports. They can go and look at it whenever they want. Like I said, the dashboards for our operators and logistics group, basically we're targeting the work process compression. The less time they can spend communicating with other people for information and the more time they can empower themselves to make decisions is just going to continue to increase throughput of the plant. So basically it boils down to the question is how is this effective process monitoring helping Grace? We're satisfying our customer demand with quality products. We're improving our process efficiency and throughput, and we're keeping employees engaged with the process and helping them understand it and reducing those knowledge gaps. Right now, we are setting the standard for what effective process monitoring is for the company. But I think from then we're going to implement it not just here at my plant, across the plants at our site, and then further expand that into other sites as well. And with that, I'd just like to thank everyone for sticking around for the presentation. Thank you to Capstone and the ARC Advisory Group for having me present today.
Hey, Ryan, that was great. Thanks so much. I assume when you were controlling the plant remotely, you weren't in Ear and Santorini. Was that?
Sadly, I was not. I was told by the wife that I had to leave the computer at home for that one.
Oh, okay. Okay, yeah, that was certainly a nice slide to pop in, especially during these times.
Oh yeah, wish I was there.
Right. Speaking of that, one of the, based on certainly what we've been going through for the last year and how well certainly Grace has been able to certainly respond to it. How ready are you, let's say, and based on what we've been going on with certainly some of the winter and climate issues we've had in the US, how ready would you say Grace is for, let's say, unfortunately, the next catastrophe, whether it be a climate catastrophe or God forbid another version or a strain of a pandemic? I mean, do you think that you're really that much ahead where your operational resilience is at the point where it's kind of like bring it on, we're ready to address it?
I don't know if we want to bring it on, but right. I will say having these systems has been majorly beneficial for us. I can't imagine how it would be trying to manage the plant as the production engineer from home if I didn't have this information on hand. Because if we didn't have this information, it's me trying to walk through with a foreman while they stare at an HMI screen and I'm blind. I'm basically relying on them to give me information that may or may not be accurate.
Yeah. Now from your perspective, Patrick, based on what, certainly the solutions that you've been providing your customers over the years, and of course, what you've been doing with WR Grace, do you feel your solutions are really further along at a point where you can, where you can help your customers even better now with their operational resilience?
Yeah, Craig, absolutely. I've been, I started out my career 15 years in installing advanced process control and optimization around the world, and I worked with a lot of different technologies. And last 20 years in consulting and in business sales, I've worked for Aspen Tech, I've worked for Honeywell, I've worked for Rockwell. Capstone brings together with Data Park a solution that is optimized in that it connects to those multiple systems. It has those great online tools.
Mm-hmm.
Data is fast. It's easy for most of the key functions. Low cost, short project timeline, and excellent post-project support. It really does provide an optimal system for operational excellence.
Mm-hmm. Yeah, definitely. Certainly we all know the amount of data in plants is certainly not shrinking. It's certainly growing. Sometimes it feels like it's growing exponentially, if not logarithmically, the amount of data in the plant. Whether it's historian data or data from brand new sources, certainly, driven by this, IIoT world. How do you see Ryan at Grace taking on that challenge of this exponential increase in data?
Oh man, I wish I had one of our IT people here to answer that. I will say the original information I showed, probably the 55,000 just over tags. I know that we've increased that number significantly. Those are some old 2018 numbers. Our LIMS data has increased significantly. Our lab data has increased significantly with the introduction of, like I said, more of our online document systems that I'm trying to get us away from paper and into that. But so far, I haven't seen any degradation. Everything continues to run smooth, and honestly, with Capstone support, it's been running smoother than our original implementation. So the speed is still there. I haven't seen any degradation.
Mm-hmm.
Can I jump in there too?
Definitely.
The project with Energy Transfer, 400 sites, 4 million tags, data tags, upwards of 1,000 dashboards. Over 600 users and rising. They're using Data Park across their enterprise to bring all this data together. And you can, being a midstream and upstream company that Energy Transfer is, you can see that the remote aspect is important to them as well. So they're able to use Data Park across their entire enterprise in a holistic way to get information to people that really need it. It doesn't seem to be a challenge there for them.
Mm-hmm. One of our, we're looking at some of the questions also that have come in. It's, how would you compare this product with a typical MES product in the market? For example, just a standard MES product. I'll let you start, Patrick, and then I'll ask Ryan, how you look at Data Park versus a traditional MES product.
Yeah, so going back to the origins of Data Park, and you look at what was going on in that shop floor back in the 80s, and the data that they needed, and the analytics that they needed, and the speed to be able to make decisions, we're really focused on that operational excellence aspect, as well as serving data up across to the different corporate groups. And so our first focus going in is on that frontline operational excellence and addressing the production issues and the quality issues and the safety and reliability issues on the plant floor, and then getting that information up as easily as possible to those stakeholders that are responsible higher up, instead of a top-down approach.
Okay. All right, what's your perspective, Ryan?
It's hard to say from my perspective because I don't think I've had enough experience with multiple MES systems. But in my limited experience, I've come from another plant where we had basically zero OT and IT technology, and coming into a system like this, and it continues to surprise me the amount of work that it can do. I would be very hard pressed to find another software that could fit in the way that this has. The ease of use, the complicated analytics that it can do, especially with process modeling that I haven't even really dove into yet. I would be very hard pressed to find something that could be as powerful as this system is.
Mm-hmm. Actually, one more of a architecture question. Are you storing the data on premise? Are you storing it in a remote cloud? I mean, where's the data go? Where are the data going, Ryan? And then I'll ask Patrick to follow up where your customers are typically storing their data.
It's probably a more appropriate question for Patrick, but I will say most of ours are just stored on servers that are, I don't know who hosts the servers, but all of which we access ours primarily through the VPN. The remote access to it, it has to be done through a VPN, and we have to be on our own specific network to get it. We are working on a workaround, especially from true mobile viewing of graphs. But I think, Patrick, you're probably the resident expert on that right now.
Well, the data typically is kept in a server, virtual, mostly virtual, or a hard server. But we do have customers who have quite extensive experience in initiatives in the cloud. And so we also store the data in the cloud for those customers. So it can be in the cloud, for instance, in Azure, or virtual and hard server in the plant.
Okay. And Orion, you mentioned that Grace is using DataPark at a number of different sites. Are those plants able to share, production data with one another for monitoring at, say, the corporate level? And what benefits do you see enabling this collaboration?
Oh, absolutely. I believe right now I still have access to a number of sites, but you do have the ability, especially with some of the newer software systems, to set up a security system so I couldn't access it if I wanted to. As far as if you wanted to keep someone like myself from accessing other information, but allow someone on a corporate level to do it, I believe it would just be a simple security setup within DataPark. For me, it is helpful that I have access to that because I am part of a inter-company team that collaborates to kind of decide like how to move forward, share ideas, what we're currently using it for, how we could be using it. So having access to their information has helped inspire me to implement stuff here on site. So I think the collaboration is good, but for obvious reasons, there would be security risk with sharing information.
Okay, how does that sound, Patrick, based on what Grace is doing to what many of your other customers are doing?
Right. Exactly. Just tagging on to what Ryan said. First of all, there are some other groups within Grace that are putting together standards. Typically, they're around certain technologies. Ryan works in one technology area, but there are others. For instance, Illumina. I think Ryan, 5 of the Grace sites have some major Illumina operations.
Mm-hmm.
So I know that there's been some standards that have been generated around, and they have groups that then discuss these technologies and they pass them on. But yes, absolutely. There is a way and an ease in which you can put technologies, a grouping of technologies together and package them to apply across company assets where operations are similar.
Okay. Another question for Ryan. How important is the speed of data access to WR Grace, and how well does DataPark address this?
Oh, I think it addresses it head on. Like you saw from the simple video I sent you over a VPN, nonetheless, 15 seconds to load multiple servers of data all onto one location is been extremely helpful. I like to say it's not my job to find information, it's my job to analyze information, because the time I spend finding it is time that I could have spent finding resolutions. So speed is critical. Like I said, our previous system, I could walk in, open 5 or 6 windows, which really doesn't even have a quarter of the information that I load now, and it would be 30 minutes to an hour and a half. And I would have plenty of time for multiple cups of coffee, but not enough time to actually solve any problems. So speed of data is probably one of the highest priorities for us as a site, and especially as an engineer.
That's something, Patrick, that you find that certainly is one of your best points of as you're presenting DataPark to your customers and prospective customers.
Absolutely, and not only speed from the perspective that the data comes quickly, and like I had mentioned before, we have a data speed framework in which we get the data to you quickly. So simple things like you might have a multi-trend that has a window where the pixels can't represent all the data that you want to pull in there. You want to pull in there a year's worth of data or something. And so a lot of technologies will deal with that data flow right when it hits it. We have a data speed
already dealt with that. And so it pulls it up quickly. The other thing too is I remember one of the places at one of the refineries we went into and implemented, I went up to the process engineer's desk and said, hey, give me an example of how this thing really benefits you. And he said, well, I used to call up a trend and it would take 20 to 30 seconds for it to populate. And he said, when it would populate, I'd jump over on my phone and he'd jump on to something else. And by the time the trend came in, he'd look up and he'd forget why he called that trend up in the first place. So having the trend pop in and you be able to look at something that you're looking for immediately and then have another thought about the next thing you want to look at and have that pop in quickly. And it might be, 4 or 5 steps before you get to the answer. To put all that together and compress that work process down, not only in speed of data, but in how things are linked, compress the time to get to the right result.
Great. We have a few more questions regarding, I'd say, more usage of the product. One of them is, does this tool have the ability to overlay batch data and compare batches in the same graph easily? So I'll see, Ryan, is that a function that you're using? And then we'll see if Patrick can also give his viewpoint on whether the capability of DataPark.
Yeah, no, it's one of the greatest tools, and I briefly showed it unfortunately with a lot of the process information cut out, but we can overlay all of our batches in just one big comparison mode, basically stacked on top of one another, or we can look at them side by side, cutting out a dead time when nothing's running. That's something that I use to determine if our reactors are running within their normal time frame. We have a lot of issues with steam traps, as I'm sure many plants do. That extended batch time is basically indication that we have bad steam traps, and I could go do a click, drag, and drop over, say, 10 batches is what I look at a time. I see extended batch times, and then I tell our maintenance group to go out and solve that issue. Something that used to be about 30 pieces of paper with approximate numbers of batch times is now a quick drag and drop over something.
Right, and the specific tool that Ryan's talking about is the Run Browser. And the Run Browser allows you to, as you said, overlay batches where you can see them in sequence. You could even compare, phase 1 of the last 10 batches of the last 50 batches, or phase 2 or phase 3. You can also identify a golden run and compare your batches against that run. You can also put in limits. So as a temperature travels, it should travel in this band. And so it'll identify whenever it pops out of that band and notify you. And you can also apply the SQC, SPC functions to it as well.
And just a little bit more on that, that's something that I think is maybe not unique to us, but a unique solution that we found through it is while we are a batch operation, we don't actually have batch tags or information a part of our servers, but we were able to make custom calculations that basically based on certain process conditions, maybe it's a level increase, a temperature increase, it doesn't matter, give it and assign it a batch ID, which allowed us to actually starting to be able to look at stuff from a batch information standpoint. Previously, we don't have that information. There's no way to go back and look at say a batch from 2 years ago and determine if something was good or bad. But now with that batch information, we can look at it. Basically creating tags and creating process information is what allowed us to use this Run Browser, which I think is another unique thing to this software.
Mm-hmm. Another question on using the product is, how do you realize error in the system and control of that error? So again, we'll let Ryan first and then Patrick.
For us, I think it was an outside development of our critical to process parameters, and then actually implementing those into tags that correlate to those critical to process quality parameters. So now we can actually look at those tags within their critical to quality parameters in real time and determine if it's starting to deviate in and out of the process. On top of that, the alarms don't just have to be in or out. They can be out for multiple steps or out for a specific time frame. All of that we can kind of customize to how the process actually runs to determine if it's a process out of control and we actually need to step in and do something.
Okay, Patrick?
Yeah, Ryan, you answered that pretty well. I'll also mention we have a principal component analysis modeling system, which allows you for a certain operation to model the normal or maybe even the exemplary operations and how that say for instance, it can work in continuous, but say for instance in batch, you've got 4 phases. You have an initial phase, a steam phase, a cook phase, and a blow phase or something. Anyway, you can utilize that PCA to look back and say, man, we really nailed it right there. So then you can put a model together, which essentially identifies where those variables should be in time and how they react to one another, and then apply that model against the current operation, and it will flag using 2 statistical parameters, a D mod X and HT2N. It'll flag when you're outside of the norm or you're heading into some kind of a problem. And this is an early warning capability that gives staff to be able to identify something before it happens.
Okay. Another question is, it's always like that Monday morning quarterback question. Whereas Ryan, if there was, after implementing this, you've had some incredible success, certainly deploying the platform. Any word of the wise saying, if I knew what I knew now, what would I possibly do different? And we'll start with Ryan, and then I'll see if Patrick has any suggestions also from a Monday morning quarterback perspective.
I think the biggest one is when I first started working with this, I got a little overzealous with the amount of information in one window. I learned very quickly to kind of split up into the multi-trends and group data together on how they behave together. Some of my early trends were busy and very hard to understand. Actually splitting up information, albeit in one window, but into simplistic views is probably the biggest benefit and information I knew when I was first working with the system.
Mm-hmm. And Patrick, as far as as you've watched certainly WR Grace, watch their journey, are there things you would have maybe suggested to them, or maybe again if you were doing future systems at different plants?
I think that Grace has really done a great job. They had from the first implementation, they came out. For instance, one aspect I'll talk about is the training. They were kind of given the fire hose training at the beginning, and then when they got to Curtis Bay, they said, "Hey, why don't we change that training up a little bit and parse it into 4-hour segments?" I think we took people in the first one. We took people in for 2 days of just blast them, but go in there and do the training on one 4-hour segment to a group of people. That gets them to thinking more. They have some more ideas, and then they can build a few things, and then come in and say, "Hey, I'm trying to do X, Y, and Z, and I can get those things done. Let's address that in terms of the training as well." And it's really a lot. Like I said, a lot of the functions are really easy to learn right from the outset. But then once you get going, you'll generate some more questions in your mind to create some things that will bring you more value. So that training aspect, I think, is one thing that they can learn from to get more value out of.
Okay, great. And then our final question of the day is, people have been pretty impressed, Ryan, with what you and Grace have been able to accomplish, but they always are looking for, how do I justify it? What do I bring up to management to help justify this?
Oh man, I think the biggest thing for us is when we brought in this software, it was only supposed to replace trending. I don't think and I joined in about halfway through the project. I don't think those who made the decision on Capstone realized what this software could do and the power behind it. It really has replaced a lot of our day-to-day operations and systems that we were using. It has improved speed. It has, like as I showed you, quantifiably saved us money, and that's just my plant. This product works, and it saves money, and it improves process monitoring and improves throughput of the process. using all the tools combined, it really is a powerful program that will improve the company.
Okay. And the same thing I say from your perspective, Patrick, as far as what do you, as far as things you want to help people with, that want to help justification process with their management?
Well, I would say a couple of things. One, there just didn't seem to be an end to requests that come from staff about having a new software tool. And many have, there's been many products that have been purchased and haven't worked out really well. So one thing is I would say, have us come do a demonstration.
Okay.
And to see the vision of what you would do. And so, being able to connect to multiple systems, for instance, BP out of Cooper River, they did a presentation for us, $3.5 million a year in benefit from connecting multiple disparate systems in which staff across the plants didn't know what was going on, just by giving visualization to the data and to the processes, and to be able to make decision based on that data about them, a huge amount of value. So that the data is fast, it's easy to use. All the things that we've said before can bring huge value.
Awesome. Well, Ryan, Patrick, was a great job today. Can't thank you enough. Seem to have great reaction from the audience. So just to wrap up here, our ARC's next Digital Transformation Council Best Practice webinar will be Thursday, March 4th, 11 a.m. Eastern Time. It's entitled Making Sense of Wireless Options for Field Operations. As far as for our next online member meeting, Succeeding with IT/OT Organizational Convergence, which is certainly a great follow-up to our presentation today. And that'll be done by one of my colleagues, Peter Reynolds. And, for those of you that attended our ARC virtual forum the last couple of weeks, those sessions are going to be active through April. So please go back and revisit some of those sessions, because there's a lot of great information that you may have, if you were in one track, you may want to catch up to some of the other tracks you may have wished you had time to listen to at that time. So hopefully you can do that. And, one of the things we always look forward to you to do is to always be joining the Digital Transformation Council. And I think you can really take advantage now of the online member-only meetings, as well as our meetings with all end users. So we really look forward to you joining that. It's free of charge, and the link is right up there in the screen. So we really if you're not already a member of the DTC, please go ahead and join. There's many benefits of membership. So with that, Craig Resnick with the ARC Advisory Group, thank you so much. And let me turn it over to Preet to wrap things up.
All righty, guys. Thank you to our speakers and presenters, and thank you to our audience members. Goodbye, everyone. Have a nice day.
Thank you.